every IP network has one address that is reserved for broadcasts. If a computer wants to send a message to all of the devices on that IP network, it uses that broadcast address and everybody will hear it. So here I've got two IP networks. Remember that routers separate IP networks. And let's say that one of these, let's say this PC up here on the top left, is looking for a DHCP server to get an IP address. Now, there aren't any here unless the router is acting as a DHCP server, which it might. But this computer doesn't know that. It doesn't know anything because it's brand new on this network. I just plugged it in. So it sends out a broadcast. And that broadcast will go to all of these devices. It'll go to these three computers and to this router. Now, each of these ports on the router is on a different network. So this will limit broadcasts going across the router. Broadcasts will stay only within that network because remember, there's only one broadcast address on every IP network. And so it will limit it to that network. It will not cross this router. So we say that routers separate broadcast domains, or each port on a router is a different broadcast domain. Now let's take a look at another concept called collision domains. It used to be, before we had switches, that very early we would just tie computers together on one single cable like this, run it around the room, and that was our network. Later on we began to use these central devices called hubs, but really they're the same idea. All the wires are just tied together in one big knot, so to speak, right here in the middle of the hub. So here's what happens. Let's say that this PC up here in the upper left wants to talk to this PC down here in the lower right in this first illustration. And at the same time, this one in their upper right wants to talk to the one in the lower left. Well, these are communicating via voltage on the wire. And if two signals get together, the voltage is going to spike and nobody can tell what the message is supposed to be. The ones and zeros are represented by different voltages. And so we have a collision that takes place. In other words, only one PC is allowed to talk at a time. We call this contention, and we call this one collision domain. The same thing over here. This PC on the left wants to talk to the PC on the right, and suddenly this PC down here in the lower right wants to talk, and a collision occurs. So again, we have a collision domain over here. Eventually, switches came along. Now, switches have the capability of allowing one computer to talk to another computer and nobody else hears the conversation. So we can have two different conversations going across these different cables and there are no collisions. These are completely separated cables. They're separated inside the switch, and the switch sends the frame to each of these PCs as it needs. So in this case, we have eliminated all collisions, or we should say that each of these ports on a switch is a different collision domain. Rather than one big collision domain, I now have 4 collision domains all off of the switch. So let's put this knowledge together, broadcast domains and collision domains, and see if we can tell how many broadcasts and how many collision domains we have. Now, by the way, I didn't mention here that routers also separate collision domains as well as broadcast domains, so just keep that in mind. So here we have 9 collision domains and 3 broadcast domains. So let's count them. Every port off of a switch is its own collision domain. So I've got 1, 2, 3. This is all one collision domain up here because that's a hub, so that creates one collision domain. So that's 4. Off of this switch, I've got some more, 5, 6, 7 off of those. But then there's a port coming off of the switch here between here and the router. So that's 8 collision domains. And over here is the 9th one between this switch and this router. So we have to take into account these segments that go between devices, between routers and switches as well. We have 3 broadcast domains. Every port off of the router is a broadcast domain. So there's 1 over here, 2 over on this side, and 3, this third one up here. 9 collision domains, 3 broadcast domains. That's a skill you'll want to be able to develop, to be able to count collision and broadcast domains.